Today's lesson's 5.11, Union and Intersection Word Problems. Today's aim is how can we solve word problems involving unions and intersections. So this is going to be the last topic that we have here. After this, we're moving on to the next skill concept. I just want to make sure that we're comfortable being able to interpret these sort of word problems before moving on. So you have this big scenario here. I want you to read it and determine who is correct and why do you believe this. The gist of it is Nushrala and Salma, shout out to you guys, are trying to find the probability that a student chosen randomly from the class plays both basketball and baseball, and they're using different formulas. So, getting into it, right, Salma would be correct in this situation. The reason why is because if you're trying to choose someone that plays both basketball and baseball, they need to include someone who does play both, and that's a word that's synonymous with an intersection. Now, let's talk formulas, right? So we learned these on Monday, but I want to review them. So, a union formula, right? The probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B. Again, right, thinking of the Venn diagram, the OR is everything, but the overlap in the middle is counted twice, so you have to subtract it in order to make it accurate. Similarly for intersections, so the probability of P intersect B equals probability of A plus probability of B minus the probability of A union B. Again, right, so union is all circles. The overlap is what you want, so you need to remove everything else so that you're left with the overlap. Now, let's talk word problems. So how do we know if a situation is a union or an intersection? Well, wording is going to be very big. So if you're going to need to use the formula for the union, you're going to look for words like either, or, at least, one or the other. A but not B. Notice they're basically telling you that one is okay, one is acceptable, two is acceptable, but you need at least one. If you're going to use an intersection now, right? Words like and, both, all, everyone, everything. So in other words, including all the possible scenarios. That's what you're going to look for an intersection. Now the big question, what about neither or nor? So to be neither or nor means to be not included in event A or B. And those of you that use the Venn diagram, you're going to think about that value as outside the Venn diagram. So, for this guided practice, there's a spinner with 10 equal errors numbered 1 to 10. The spinner is spun one time. You're going to answer these 4 questions based on this scenario. My hint to you is make a Venn diagram. At least to put your numbers 1 to 10 in the right spot. It'll make it so much easier to calculate the probabilities. I promise you that. Because, let's get to it. So, here's my Venn diagram. My multiples of 2, there's 5 of them. My multiples of 3, there's 3 of them. My multiples of both, there's 1 of them. And then we'll discuss more about the outside area. But we're going to reference this. Alright, so, what is the probability that the result is a multiple of 3? So, let's talk. I wind up with 3 out of 10, but how? Well, 3, 6, and 9 are all multiples of 3. What is the probability that the result is a multiple of 2? Well, again, I listed them out. So 2, 4, 6, 8, and 10 are all multiples of 2. So that's your 5 out of 10. What is the probability that the result is a multiple of 2 and 3? So this is your union. This is your intersection, excuse me. And that's only 1. Only 6 is a multiple of both. Now, what is the probability that the result is a multiple of neither 2 nor 3? So now we're talking about the not, right? Well, first off, you could think of it in numbers, and that's why we use this as an example. 1, 5, and 7 are not divisible by 2 or 3. But thinking about how you would solve this, you would do 1 minus the probability of A union B. So in this case, 1 minus the probability of being a multiple of 3 or 2. Well, we know that the probability of being or would be what? It would be 8 out of 10 minus the intersection, which would be 1 out of 10. So that would leave you with 7 out of 10. So that's what the probability of being or is, 7 out of 10, or 70%. Therefore, 1 minus that union would be 1 minus 7 out of 10, leaving you with 3 out of 10. Alright, so you have some data here that I pulled from Calabasas County Public Schools about their skipping classes and GPAs. So you have 3 questions here I would like you to answer. When you're done, you can submit your assignment. I'll post the results from this independent work on Friday. For those of you that were asking questions about the Desmos, I'm posting those all completed challenges in a document with this lesson. Alright, so be on the lookout for that. That's all for today, guys. Have a great day.